But that would prove merely to be a warm-up for the epic battle looming on the horizon. Round 2. You know what happens in science? Sometimes you resolve one problem only to open up a whole nother can of worms. And that is what happens with the discovery of special relativity. It surely does resolve the puzzle of light speed, of why we never see stationary light. But in the process, it reveals another puzzle to do with a different speed, the speed of gravity. In the late 1600s, Isaac Newton wrote down his famous universal law of gravity, which says that every object in the universe pulls on every other with a force that depends on two things: how big the objects are, their mass, and how far apart they are in space. And using the little mathematical version of that description, we can make predictions for the motion of moons, planets, comets, and it all works, which is great. The problem has to do with the speed with which gravity exerts its influence. Here's what I mean. Imagine that for some reason, and the details do not matter, the sun is plucked out of space. It's gone. Here's a question. How long will it take for us to learn that the sun has disappeared by the sky going dark? Well, how long does it take light to travel from the sun to the earth? About 8 minutes. Which means if the sun were to disappear right now, the earlier light it emitted will still be streaming toward the earth, still be streaming toward the earth, still streaming, and only 8 minutes later will the final light that the sun emitted blow by planet Earth, and the sky goes dark. By comparison, how long will it take for us to learn that the sun has disappeared by feeling it? And I don't mean like feel it emotionally. I mean feel it physically. The sun keeps the earth in orbit, so if the sun disappears, our motion through space will change. But how long will it take for us to feel that change in our motion? Well, according to the equations of Isaac Newton, at the very moment that the sun disappears, its gravitational pull will also disappear, so we will be flung out of orbit immediately. Which means we will learn that the sun has disappeared by a change in gravity 8 minutes before we learn that it's disappeared through a change in light. Gravity going faster than light. That flew in the face of special relativity's dictum that nothing can go faster than the speed of light. What to do? Well, Einstein realizes he needs to resolve this problem with the speed of gravity. And to do that, he realizes he needs to get a handle on how gravity works. You see, the formula that Isaac Newton gave us describes the influence of gravity, but it does not tell us how gravity exerts that influence. I mean, how does the sun keep the earth in orbit? You say it's gravity, but there's no rope, no tether, no arm that reaches out. So by what mechanism does gravity exert its influence across the vacuum of empty space? This was a question that deeply troubled even Isaac Newton himself.
It is inconceivable that inanimate brute matter should, without the mediation of something else, affect other matter without mutual contact. That gravity should be innate, so that one body may act upon another at a distance through a vacuum, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it.
And yet, even though Newton aspired to go beyond that absurdity, he was never able to answer the question of how gravity works.
I leave that question to the consideration of the reader.
Yeah, sure. For the following 200 years, just about everybody who read that, they kept on reading. Here's where Einstein is different. He is motivated to figure out how gravity works, and one afternoon in the patent office, Einstein sees the way forward.
In 1907, I was preparing a summary of the results of the special theory of relativity for the Jahrbuch der Radioaktivität at the request of Stark, the editor of the journal. I was sitting in a chair in the patent office at Bern. Suddenly, an idea dawned on me. If a man falls from the roof of a house, he must not feel his weight himself. I was startled. It was the happiest thought of my life.
The happiest thought of Albert Einstein's entire life is a man falling from the roof of a house. But the reason this thought made Einstein so happy is that within it, he could see the key to a generalized version of relativity that would embrace the force of gravity. Here's how I can think about it. Imagine that I am the guy who in just a moment Einstein will see falling from that roof. But just before that, I'm on the roof, standing on my bathroom scale. I look down at the scale and it reads 160 pounds. Then, with the scale Velcroed to my shoes, I jump. And as I'm falling, I again look down at the scale. What will it read now? Well, because the scale is falling right with me, I'm unable to press down upon it, so the reading on the scale will drop all the way to 0. By going into free fall, I feel weightless. And it's not just the scale. If I were to empty my pockets, everything will also fall right with me. So as I look over, it'll all be hovering right next to me, exactly as it would if there were no gravity. So in this sense, from my perspective, I have canceled gravity out. What about from your perspective? Watching this from the ground, well, you will surely say that there is gravity, right? It's what's pulling on me, causing me to fall faster and faster, causing me to accelerate downward. It's not as though one perspective is right and the other is wrong. Both perspectives are right, yours and mine. And therein lies the power. By putting the two perspectives together, Einstein realized that there is a profound connection between acceleration and gravity. You see accelerated motion, my falling faster and faster, and I see gravity being canceled. And this is one of the rare insights of Albert Einstein that you can verify at home, safely. All you need is a bottle of water. Water is spraying out of those holes because gravity is pulling on the water. But if we let the bottle drop, then from the water's perspective, gravity will be canceled, and so it should stop spraying out. And it does. Accelerated motion canceling out gravity. Now, the reverse is also true. Accelerated motion can masquerade as gravity. It can mock up a force that's indistinguishable from the pull of gravity. That room. It's in completely empty space, no gravity. And yet, if we turn on a couple of rocket boosters, making the room accelerate upward, everything inside feels pulled downward by a force that feels just like the pull of gravity. That feel like gravity?
Big time.
So the upshot is that with his happiest thought, Einstein realizes that he can seamlessly trade off accelerated motion and gravity. And this proves to be the vital leap forward, because understanding gravity, that was surely difficult. It had stumped Isaac Newton and everybody else who thought about it for 200 years. But understanding accelerated motion, that didn't seem so bad. So Einstein sees accelerated motion as his newfound hammer for cracking the problem of gravity, figuring out how gravity works. And it would not take long for this strategy to bear fruit, to reveal a connection between gravity and another startling concept: the curvature of space and time. When Albert Einstein has a new idea, a good idea, he does not let it go. He shakes it, he twists it.